Welcome to the PEAKS 12 PTM and Spider video tutorial. In this video, I will explain the PEAKS solution for post-translational modifications and sequence variant analysis, the workflow setup, and how to view the results. Post-translational modifications and sequence variants introduce complexity in the proteome. This complexity makes proteomic analysis challenging. Over 600 PTMs are reported in the UniProt database. However, software is limited in that only a few PTMs can be specified in a typical database search. Specifying too many PTMs causes an exponential growth of the search space due to the multiple possible modification sites per peptide. This will cause an increase in analysis times and will increase the potential for false discoveries. Also, users don't always know which PTMs to specify in the database search. This ultimately results in more limited coverage of the proteome. PEAKS PTM addresses these challenges by introducing an algorithm whereby unlimited PTMs can be searched. In the PEAKS workflow, the raw MS2 spectra are de novo sequenced, followed by a database search. In this database search, a limited number of more frequently occurring PTMs are specified to try and keep the search space controlled. The PEAKS PTM search can then be run to identify additional PTMs. In this round of the search, only the spectra that meet a certain de novo score and were not assigned to a database peptide are searched. PEAKS provides two different types of scores on peptide spectrum matches with a variable modification. The peptide minus 10 log P score is the probability that the modified peptide is a true match to the database peptide, whereas the ACE score is the probability that PEAKS assigned the correct modification site compared to any other possible modification sites on the peptide. For both minus 10 log P and ACE score, a score of 20 indicates a 99% confidence that this is the correct match. PEAKS has hundreds of built-in modifications. You can also add your own custom modifications. You can create entirely new ones, or you can duplicate and edit pre-existing built-in modifications. You can also add in parameters such as neutral losses. You can also add information such as neutral losses, which help distinguish between isobaric modifications, such as phosphorylation and sulfation. Signature ions can also be included in the PTM configuration and can provide an additional level of confidence in the result. PEAKS will detect how often the signature ion is found in spectra that match the modified and unmodified peptide. If the difference between the percentage of the modified peptide spectra matches and the percentage of the unmodified peptide spectra matches with the potential signature ion detected is large enough, the signature ion will be used in peptide rescoring. You can tell PEAKS to find potential signature ions for you without having to predefine them, or you can add your own confident signature ions in the PTM configuration. Some of the PTM confidence parameters can be altered under the algorithm configurations. The minimum peptide tag length and the minimum peptide tag ion intensity required for a PTM to be considered confident can be changed. In the Modified Peptides tab of the result, confident PTMs will be displayed in green, while unconfident PTMs will be displayed in red. The requirements for a potential signature ion to be used in the rescoring can also be changed. In addition to PTMs, PEAKS can also search for sequence variants. In addition to PTMs, PEAKS can also search for sequence variants using the Spider algorithm. Following a database search and the optional PEAKS PTM search, the Spider search can be run. The Spider algorithm takes de novo tags and attempts to match them to database proteins. PEAKS considers the possibility of de novo sequencing errors and mutations to reconcile the differences between the de novo tag and a similar database peptide that is not an exact match. Like with PTMs, you can alter the peptide tag length and peptide tag ion intensity required for a mutation to be considered confident. Again, this can be done under the algorithm parameters under configurations. Like with PTMs, in the Mutated Peptides tab, confident mutations will be displayed as green, and unconfident mutations will be displayed as red. Now, let's go into PEAKS and take a look at the workflow setup. To access the PEAKS PTM and Spider searches in your analysis setup, choose the PEAKS DB workflow. Select your data refine options, and set up your database search in the same way you would for a typical DDA database search. Under Set PTM, we recommend setting a few common variable modifications. This helps keep the search space well controlled. To perform the PEAKS PTM search, check Find Unspecified PTMs with PEAKS PTM. You have two different options here. You can choose to search all built-in modifications, or if you don't want to search them all, you can select a list of modifications to search. Click on Additional Modifications. This brings up a window where you can select fixed and variable PTMs to include in your search. You can also choose to find potential signature ions here. Finally, you can set the minimum average local confidence needed for a de novo spectrum to be considered in the search. To perform the Spider search, select Find Mutations and Sequence Variants with Spider. Next, you can set up your quality control step if desired. And finally, select your report filter parameters. Once you have done that, select Finish to run the analysis. Now let's take a look at some sample results. When you've completed an analysis that involves the PTM and Spider searches, you'll notice a couple of extra result tabs that you can click on: PEAKS PTM and Spider. These results are additive, meaning that the Spider result, as the last step in the analysis to be run, will contain information from all other steps of the search. So if you wish to view the most complete result, you should choose the Spider. So if you wish to view the most complete result, you should click on the Spider result to view. However, to start, I'm going to show the PEAKS PTM result. The summary page and all of the other result tabs are laid out in a very similar way as the database search result. I'm going to highlight one particular figure that is exclusive to the PEAKS PTM result. If you chose to search for potential signature ions or to find any signature ions in your custom modifications, then you will see this table and this figure showing the statistics about your signature ions. Table 5 lists all the detected signature ions with some statistics and whether or not the detected signature ion is a potential or if it's expected. Figure 6 shows a frequency plot of detected signature ions. This plot shows the frequency of the signature ion and both the peptide spectrum matches that contain your PTM and those that don't. Now I'm going to take a look at the Spider result. Again, you can see the summary page looks very similar to that of the DDA database search. There are some PTM confidence parameters that you can set at the top of the summary page. Here you can set the minimum A score and minimum ion intensity as a percentage of the base peak required for a PTM to be considered confident. Looking at the Proteins tab, we can now see the additional modifications and mutations that were identified by the PEAKS PTM and Spider searches reflected in the protein coverage view. The Modified Peptide tab will be present on any DDA database search result, PEAKS PTM result, or Spider result. In this tab, peptides in the chart are arranged as pairs with their modified and unmodified form, assuming both are found in the sample. Confident PTMs are displayed in green, and unconfident PTMs are displayed in red. The ACE score for the modification can be seen in this column here. You also get a mirror plot showing MS2 of modified and unmodified peptides. The mutated peptide tab is new to PEAKS 12 and is available in the Spider search result. Much like the modified peptides tab, peptides here are paired with their mutated and wild-type forms. Confident mutations are shown in green, and unconfident mutations are shown in red. Like with the modified peptides, you get an MS2 mirror plot with the mutated and wild type. If you click on the Export tab, you'll see some additional results that you can export. You have the same options for export as you do for the database search result. PEAKS PTM exports will include results from PEAKS PTM and database search, and Spider exports will include results from the Spider search, the PEAKS PTM search, and the database search. As well, the Denovo only results are available. Again, as these results are additive, if you wish to export the most complete result, you should choose to export the Spider results. Choose the results that you want to export, choose the folder where you want to save it into, and click Export. We hope you enjoyed this video tutorial on the PEAKS PTM and Spider searches. For additional information, please visit our website, bioinfor.com. Thank you for listening.